Okay, we are up and going with Algebra 2 EOC Review Day 3, and I am genuinely hoping that Desmos is more cooperative today than it was in the last video that I recorded earlier this week. If it's not, I will probably quit and stop this video. So fingers crossed on that, okay? What I'm going to do in this video is I am going to back up due to the fact that I was out and I had one class this year that pretty much all you got for the last review was a video. And with my classes that I was here, we didn't make it all the way through all of the problems that I had hoped for. So I am going to back up about 2 or 3 questions into the last review. If you already watched the video for that and you understood it and it wasn't so messed up that you couldn't follow along, then feel free to take this video and fast forward through those problems to get to the problems that you haven't covered yet. Okay, so that's totally fine. Just letting you know at the outset that that is what I intend to do. So going back to question 12 on the review packet, it's which characteristics describe the functions shown on the graph below. And to do this, it requires remembering about like even and odd polynomials, okay? And so if we look at polynomials, the polynomial y equals x is an odd polynomial because the exponent is odd. And the polynomial y equals x squared is an even polynomial because the exponent is even. Now, what we can do with this information is we can use this information to help us move to other odd degree polynomials or even degree polynomials because they all behave the same way. Math is consistent like that. So with y equals x, that is simply a line. Okay, and the way I taught that in class was we would say it was like a line. If the leading coefficient was positive, it would tilt up like a line, and if the leading coefficient is negative, it would tilt down. A even degree polynomial will behave like a parabola. Now, it's not necessarily a parabola unless it is degree 2, but the end behavior will be like a parabola, and that would point up if the leading coefficient is positive or down if the leading coefficient is negative. So when we look at this particular polynomial in number 12, if I look at the end behavior, okay, we have it going down on the left and up on the right. Well, down on the left, up on the right corresponds to this, which means that it is going to be odd. This is an odd polynomial. If the two ends were pointing in the same direction, it would be an even polynomial. So looking at my answer choices, I have degree is odd, degree is odd. And so that's good. I don't have any that say degree or even. That's good. Then it says the leading coefficient is positive. The leading coefficient is negative. Well, if I look at this over here on the left, the leading coefficient is positive. So I'm going to eliminate answer choice D. So that is an odd polynomial with a positive leading coefficient, which means that when it says the leading coefficient is negative, then it's not that. Now, the second part of this, to narrow it down, it says, if I look at my answer choices there, it says, and the multiplicity of the 0 at A is odd. Multiplicity of 0 at A is even, and multiplicity of 0 at A is odd. Now, honestly, from there, if you're really good at multiple choice questions, you can figure out that the answer choice is probably B, because we've eliminated this one because the leading coefficient can't be negative. But look at this. Degree is odd, which we know is true. Leading coefficient is positive, which we know is true. So we know that both of those are true. It's odd because it's like a line, and the leading coefficient is positive. And then the other part of it is the same. Multiplicity of the 0 at A is odd. Multiplicity of the 0 at A is odd. Both of those, if they were like correct, if the multiplicity of the 0 at A was indeed odd, both of those would be correct. Now, that can happen if somebody writes a terrible test, but hopefully this isn't it. Therefore, probably the multiplicity of the 0 at A is even, because then B would be the correct answer choice and you wouldn't be straddling between the two of those. And that is indeed the case, but let's go review the content. Okay. if it crosses at a particular zero, so if you look over where I'm highlighting the graph, that is what's called odd multiplicity. It just crosses one time and the zero only shows up once. If it touches or bounces off the axis, that means it has even multiplicity. So what that means is something like this. It means that you might have like x minus 2 and then x minus 2 again. And the way that shows up on the graph is that it comes up and it's almost like it counts twice. It counts going up and it counts going down. Now, it not necessarily means that it's like appearing twice. It could be appearing 4 times or 6 times. The point is it's even. And then the other ones are all odd multiplicity. So it is answer choice B. Now, that is terrible writing. Okay. Odd. Okay, now, but notice what I did earlier. We've got this savvy test taking kind of skill thing where maybe the only thing you can figure out about that is that the leading coefficient is positive. Like that's the only thing you can figure out about it. The leading coefficient has to be positive. Well, that's going to eliminate answer choice D. And then you can kind of look at those answer choices and say both A and C would work if it were true that the multiplicity at A was odd. So probably it's not odd. It's probably even because that's the only way you could eliminate an answer choice. So you can do stuff like that if you have the patience to read the answer choices and just figure stuff out like that. You can actually answer these questions with limited amounts of information. Okay, but what you should be writing down in your EOC packet is the notes that I have over here. So you probably want to write this stuff down because that is the review material. That's why we're reviewing for the EOC. We did cover that at some point in the year. You took a test on this and it should be reviewed. But I know that it gets old, it gets stale, and we need to have those refreshers on that. Okay, so yay. Okay, for this one, now I'm going to click on the calculator, and what I'm really hoping is happening is it's going to change the whole viewing window. And it did. Okay, maybe that's a sign that Desmos is going to work the right way. All right, so this is a quadratic. Take a look at the answer choices over here. In my answer choices over here, you can see that this is a quadratic formula problem. Now, you do have the quadratic formula on your reference sheet, which I have here, okay? Quadratic formula is up in the upper left. So you do have the quadratic formula and you have access to Desmos. So you can plug those numbers in, dump the whole thing into Desmos and see what happens, okay? But I did this a different way, okay? So I'm gonna look at a couple things. Notice with A and B, that you have an I, all right? So that would be imaginary solutions, and that means that the graph would not cross the x-axis. If this graph does not cross the x-axis, then we have to come back and figure some stuff out with the quadratic formula. I actually wouldn't even bother doing that. I would just look at the 6 or the -6 and see if I could figure that part out, okay? If the solutions are real, then I should be able to see them and I should be able to play mix and match with my answers until I can find them. So let's go ahead and open the calculator. And I'm going to go ahead and graph my function. Okay, and what I'm going to do is do the equals y instead of the equals 0. And unlike the other day when I tried to do this and nothing would happen, I can actually get both of those. So this is much better. All right, so I can see where the solutions are. So this is good news. So even if you don't remember how to do the stuff with the square roots in Desmos, you are not picking A and B. Don't pick A and B. A and B have I's in them. And this problem obviously has real solutions because you can see them on the number line, okay? So the solutions are -1.071 and 13.071. What we need to figure out is which of those two answer choices over there matches those decimals. So what you would probably do is you would, on your scratch work, okay, make a note of what the decimals are, because as soon as I click off of them in Desmos, those numbers are going to go away. Okay, I can click back on them later, but I'm going to write down what I know the solutions are. And here's what I'm going to do. Answer choice C, -6, and then it could be plus or minus. Okay, I don't know. Again, only do one at a time. 5 root 2. And that gives me one positive 1.071. That is not what I have as an answer choice. I had negative 1.071. And yes, positives and negatives do matter. You cannot just glance at the numbers. You need to make sure that you have those correctly done. Now, if I wanted to double check that, I could do the -6 minus 5 root 2. Okay, and you notice that like these are like the right numbers, but the signs are flip-flopped. Okay, so not answer choice C. Now if short on time, I'm just gonna bubble in D. I'm gonna mark off D because I've eliminated A and B because of the I, and now I can eliminate C because the decimals don't match. But if I've got the time and I'm sitting here after school on a Friday, so why don't I have the time? I'm going to go check answer choice D. The only thing different about answer choice D is that it is a +6 instead of a -6. So I'm going to go ahead and just edit that. I'm not going to delete the whole line. And lo and behold, I have the answer choices I want. And that, for most of you, is going to be a faster way to do that problem than trying to navigate your way through the quadratic formula. Okay, now you can do this with the quadratic formula. Okay, so you can do stuff like the opposite of b. So the opposite of 12, -12 is 12, plus, and you have to do the plus or minus, the square root of b squared, which is -12 squared, minus 4 times a times c, with the negatives in there. Come out here. I don't know if I came out there. Close that all over 2 times 1, and there's my 13.07. Okay, I wouldn't do it that way. So, before you move on to the next problem, consider the different ways that you have like an option for doing this, and then decide on what would work best for you. Now, just because I don't prefer a certain way doesn't mean it's not the right way for you. Okay, because your math background, my math background, the way we think through the problems is not necessarily the same. So before you move on, think about what would be the best way for you to do this problem. Right, now this one you'll notice does not have Desmos. Desmos cannot actually bail you out on this one. You are going to need to work this one out on your scratch paper. Word about scratch paper, make sure your scratch paper is organized. That can be hard to do when you're in the groove of a test. You're just scrawling stuff down. That in the event that you need to abandon a problem and come back to it later, you need to be able to find that scratch work in some kind of ordinary way, or you're going to be starting the problem over from scratch, which we don't want to do. So a couple things to remember about this. Remember that I is equal to the square root of -1, or the other way we can think of I is I squared is equal to -1. So which one of the, now it's the same definition. Like, let's be honest, that's the same definition, just one of them is written with the square root and the other one is written with squaring. So you could get the second one if you square the first one, okay? Which one of those you use depends on the problem. If you're simplifying a square root, you're probably going to use the definition on the left. If you are doing a problem like this with imaginary numbers, you're probably going to use the definition on the right. Now, notice this piece, okay? 7 minus 2i all squared. You have to follow order of operations, which means you have to subtract before you square it. You can't just do 7 squared minus 2i squared. okay? Because then you'd be squaring and doing the subtracting after you'd square. And you might say, well, Miss Taylor, it's 7 minus 2i. You can't do the subtraction. This is true. You can't. Therefore, we got to find another way around it. And the way around it is this. Let me copy the problem over. Okay. Minus 25 minus 12i is to say, all right, well, I can get around it by doing this. 7 minus 2i all squared means 7 minus 2i times 7 minus 2i. Now we're actually going to do the squaring. We're going to square it, but we haven't done the subtraction, so we don't have to worry about it. We're going to square it without having to, yeah. So let's go through and multiply this. You can distribute, do the distribution, or you can do an area model. I'll do the area model down here. So we have 7 minus 2i and 7 minus 2i. 7 times 7 is 49. 7 times negative 2i is negative 14i. This is positive. Oh, wait, that's a negative. Negative 14i again. And then negative 2 times negative 2 is positive 4. And I times I is I squared. So we have over here 49 minus 14i minus 14i plus 4i squared. And then right here, just we're going to go distribute that negative through. So we will have minus 25 plus 12i. And from here on out, we need to do some simplification. So what do we have going on? I'm going to do these two together. That's minus 28i. And then 4 times I squared. Well, I squared was negative 1. I'm just going to copy these down. So we have 49 minus 28i minus 4 minus 25 plus 12i. What can I do with this? I got to do the whole thing, don't I? Unless I do the i's first. Do the i's first. Negative 28 plus 12 is what? I'm doing some scratch work off to the side here. That is 16, negative 16. So that is negative 16i, which means it's not A or C. And I got to do the rest of this. I need to do 49 minus 25, which is 24, minus 4 more. So that is 20. So 20 minus 16i is answer choice D. Now you could see much easier problems with the i's. So this is one of the more challenging ones because it involves subtraction and it involves multiplication. And to make it even trickier, it's got multiplication with the squaring thing going on. So you got to remember to do that little squaring the binomial with the area model. Okay, so this is on the more challenging side, but it reviews a lot of the stuff with our imaginary numbers. So that's good there. Okay, here's my, okay. All right, I clicked myself out. I cannot scroll, and I've got to learn not to scroll. Okay, so this problem, there's a way to do this without your calculator, but I would not recommend it. And also, there's no reason to do this without a calculator. There's just no reason. So let's see if I can do this the right way. I scrolled down on I can't scroll. On my scroll wheel on my mouse because it advances the slide instead of scrolling on the thing that I want to scroll down on. So this is why we skip problems that look like they're going to be really long. Okay, or problems that start to frustrate us, because problem 8, if you recall, was a mess, and I had to do a separate video for problem 8. It was a very long problem. There was another problem that was pretty long in there too, like problem 10, that were long problems. This is not long at all. You can answer this problem and do it really fast and really confidently, and every question that you get right matters. So we can do this by just dumping it into Desmos. So I pull that up, click functions, and this is where I scrolled earlier and I can't scroll. Have to click down. We go down to calculus, where it says log base A, and then it's going to allow us to type that in, log base 3 of 1/9, and the answer is -4, and it's literally as fast as that. Some of you on your regular in-class test that you were allowed to use Desmos on, you were doing stuff to evaluate logs that never should have been done because you had a calculator that would do it for you. And so I was seeing people do stuff like the log of 12 is the log of 4 times 3, and then splitting it up using properties, and then using properties of logs that we never discussed in this class. Little suspicious when that happened. I mean, a lot suspicious when that happens. But in this case, you just want to dump this in. And so the answer is -4. And then we go on with our lives very, very confident that we have answered a problem correctly on our final. And again, every problem counts. Okay. We don't know this year what that threshold or what that number is that is going to determine like a B, a C, and so forth. So we don't throw away any problems, and we don't waste time on problems when we haven't checked to make sure we've looked at all of the problems. Okay, so that one, hopefully nobody spends too long on. I debated on this one whether I wanted to open up a Desmos window or not, and I obviously decided against it. I think the next slide will have a Desmos window. I really hope the next slide has a Desmos window. I can't tell looking at it from here, but it should. So you could do this in Desmos if you needed to. And I'll show you a strategy that would work for that on one of the future ones, okay? But I thought this one was worth just doing out. Okay, so this is collapsing of the logs. Now, hopefully you can eliminate 2 of these answer choices right off the bat because there is no way these are correct. Actually, you could probably get the answer without doing any work. Now that I'm looking at the answer choices, like, I think I could do this without doing any work. Here's what I would do. Never, ever, ever, when we are collapsing logarithms, do we have multiple logs in it. And so I can eliminate A and D because we do not ever see a log divided by another log. We actually have not seen that except when using the change of base formula, okay, which is not what this is. So when we're collapsing, the goal is to write it as a single logarithm. Well, if I have 2 logarithms in that, that's not a single logarithm. And that's something that if you're good at words and you know what the word single means 1, okay? And then you look at single log and you look at these answer choices and you see answer choices that are not 1 log, then it's not single. Don't pick that. Now, between the 2 that are left, I am not picking C because there is no Y in that. And unless I have some reason to think that the Y's are going to cancel out, which I don't have a reason to think that they're going to cancel out, then I'm not going to pick that. I'm going to pick something with the Y in it. So if I had to guess on this without knowing anything about how to actually collapse logarithms, without even looking at my properties, I would pick answer choice B because single log, and because in C, the Y's have canceled out. Now, that might feel a little bit risky. You're like, well, maybe the Y's do cancel out. Maybe they do. If I had, in the problem, if I had 7s, if I had 7 here and 7 there, then I might be more careful about that. But the fact that those 2 numbers don't match, I don't think the Y's are going to cancel out. But if it was 7, okay, then like maybe something about the Y's would balance with the 7s and it would cancel out. And that's why I don't think that's what's going to happen. Okay, so if it were me and I'm taking the EOC and I'm running out of time and I don't have time to actually work through the mechanics of this problem, that's what I'm doing. Okay, that's like your test taking stuff. Now, that being said, let's go and review how we do this. This is an L. It's not an I. I saw that on your test. I mean, I knew I would, even though it says in your notes. It's not. All right, so first thing we do is we're going to move the coefficients into the exponents. So I'm going to have the natural log of xy to the 7th minus the natural log of yz to the 5th. Then when I go to collapse subtraction, it will collapse into division, but it's only one log. Okay. So right there, I am thinking, now the y's are not canceling out. This has got to be b. But let's see if we can get there from here. If you have an exponent outside, it goes with everything inside. So that's x to the 7th, y to the 7th. And then in my denominator, it's y to the 5th, z to the 5th. When you look at your y's, okay, remember this reasoning process that we've got here? If I have 7 y's on the top and 5 y's on the bottom, okay, I have 7 on the top and 5 on the bottom. We're going to cancel a bunch out. Cancel, 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 cancel. Okay. When I've canceled everything out, I have 2 extra y's, and they are going to be on the top. All the ones on the bottom are going to cancel out. So that's going to leave me with x to the 7th, y squared, and then the ones on the bottom cancel out, and I get z to the 5th. So I am confirmed now in my algebra that B is the right answer choice, but I could have gotten there faster just being observant about what the answer choices look like and about the words in the question. Okay. Savvy test taking skills. It's not cheating. I didn't photo math a thing. I did all the thinking and all the work myself. I just think about the problem a different way. Okay. And that's the kind of, when you guys have lots of high stakes tests that we want to get good at. This is one that I want to explore how, I mean, there's a lot of different ways you can do this. So I'm going to take you through like how I would do this, because this is a nasty problem, okay? This has got some big numbers, and you might not remember how to do the math on this, okay? So I do want to review some of the concepts going on here. So we are being asked to add the radicals together, okay? Looking at my answer choices, I am going to eliminate something. I'm actually going to eliminate 2 somethings right off of the bat, okay? Things that I am reasonably sure that these cannot happen, okay? And let me think of 20, yeah. Okay, that I am sure can't happen. And I'm going to eliminate C and D. And the reason I'm eliminating C and D is because when I add radicals together, okay, I have to get the same radical. So I would have to get like them to match. Never, ever, ever in any of our problems where we have simplified radicals to try to get them to match have we ended up with a bigger number. We are always making the numbers smaller. Okay, so while I might be able to take the 98 and get that down to a 29, I can't, but in theory it might be possible. Okay, I've never looked at a problem where we have taken an 18 and gone to a bigger number. So I don't think over there I am going to end up with a 29 under my radical. Okay, that just doesn't, that we don't go to bigger numbers. So when I go to simplify this, I think I'm going to simplify it down to a 2. Okay, so that leaves me between A and B. So if I'm running out of time, I'm going to pick between A and B. Okay, and you can pick, like, I mean, if you want, we're going to do a little bit more work and get there, and then I'm going to show you how you can do it on Desmos. But I'm not picking C and D because how am I going to get a bigger number under there? Okay, now here's my little trick. Remember I said in an earlier video, the thing with multiple choice questions is that you can often get to the right answer choice by only doing a part of the problem. So what I'm going to do here is completely ignore the number part. And I am just going to look at the m to the 5th. Okay? M to the 5th. That is m times m times m times m times m times m. This is a square root. I am looking for groups of 2. I have 2 groups of 2. The square root of m squared is m. The square root of m squared is m. And then I have 1m underneath. It's got to be a. And there we go. Okay. And that's how I would do the problem. So if you're wondering how would Miss Taylor do the problem, I am not going to work that problem from beginning to end and try to get the prime factorization of the 98 and the 18. It's too much work. What I do know is that when I add radicals, I need to have the radicands match. I know that when you simplify radicals, the numbers get smaller, not bigger. So I don't think this is going to be 29m. And then all I did was look at the part with the m because it's easier to simplify radicals with the m than it is with those messy numbers. And that was all I needed to do. I didn't need to do the whole problem. Now, that being the case, let's say you are not at all confident on that. Okay, you're like, that was math voodoo, Miss Taylor. Okay, that was totally math voodoo. I don't think I can do math voodoo. Can you show me another way that I could get the answer? Okay, and I'm going to time myself doing this. So it is almost 4 o'clock, and I'm going to start right now. So what I'm going to do is type in 98m to the 5th. Oh, I want to get out of my square root plus 4 square root. Oh, I can't use the m. Okay. I had to use x. Okay, so hang on, and I got to go change the other one over to an x. Because, okay, notice that that does indeed give me a graph. It's a weird looking graph. I don't think it's a particularly useful graph, but it gives me a graph. Now I'm going to type in all of my answer choices. And just for the sake of this, like, I mean, I would probably start with the first one. So 19x squared. 19, how would I type it right? 19x squared square root 2x. And what do you notice about the red graph and the blue graph? Oh, they match up. That's what you're looking for. You would look for where they match up. Now, let's just say like the first one isn't the one that works. Remember to be efficient. So only edit the part of it that you need to edit. So the only difference between the first choice and the second choice is the exponent. Okay, that doesn't match up. Okay, so not answer choice B. To get answer choice C, I have to change the 19 to an 8 and the 2 to a 29. It's close, but it doesn't match up. And then to get the last answer choice, we're going to get rid of the x underneath, which is totally changes the shape of it. And this becomes m to the 5th. That's not even close. Okay. And so just to confirm, let's go back to that first one. Okay, and it matches up perfectly. That took me about 1 minute, 10 seconds. And that was with me typing the whole thing in. It was with me making a couple of mistakes in my typing. And I went and checked all the answer choices just to get like a time frame for how long it would take if like the first one didn't work. But you can do the problem that way as well. You can type it in and you're looking for the graph that matches. You could also do that logarithm one on the previous slide. You could do that the same way as well. Okay, so that's like another option. And again, if you're using the tools that you are permitted to use and you're using your knowledge of how things work with graphs, then you're using just different knowledge in order to arrive at that answer. All right, and now let's take a look at this last one. And some of you might be thinking, hey, that little trick that you showed us, Can we do that on this one? It would certainly be worth a try, especially if you're getting freaked out by those fractions and you know that the graphing utility will handle those fractions for you, okay? Now, you're not supposed to do it that way. So let's look at this the way that we're supposed to do it. The rule that you're supposed to use here is if you have something to a power raised to a power, you can multiply those exponents. And so we would do, in this case, m to the 16 thirds times 1/4. When you multiply fractions, you just multiply straight across. So that is not an equal sign. That is m to the 16 over 12. And then simplifying 16 over 12, both 16 and 12 are divisible by 4. And so that would be 4 thirds. And then changing that over to a radical, the denominator is the index, the numerator is the exponent, and then you're like, blast, that doesn't match any. That, well, okay, now, just hang on, guys, I'm gonna come right across over here, okay? The cube root of m to the 4th means that we are looking for groups of 3. So the cube root of m to the 3rd is m, and I end up with m cube root m, which in this case looks like it's answer choice 3. I did not time myself doing that, but I've been on the slide for 1 minute, 48 seconds. Okay, so for me, that was like less than 1 minute, 48 seconds, because I prefaced it with some stuff about using Desmos. So maybe in the ballpark of a minute. Now, could you use Desmos to figure that out in the event that you did not remember how to do that math? Yes. Now, just remember, you have to use x instead of m. And this is going to look messy. This is an exponent raised to an exponent. I actually don't know what this is going to look like. So x to the 16 thirds. Come out here, close the parentheses, to the 1/4. No, wait. It's not doing it. X to the... Okay. Nope, not doing it. Not. I'm just wondering if that'll do it. Okay, I don't know what that was. We're gonna undo that. Subscripts cannot be empty. It kicked me into a subscript. Hang on. Like, it's just getting messy. I'm clicking back. I think that was like the first thing I did, and I think that will work. I think that'll work. 16 thirds raised to the 1/4. I think we're okay with that. It's because the exponents ultimately are going to be multiplied. I think that's okay. I'm not 100% sure that's okay. All right. Well, we're going to find out. Life is an adventure. All right. So over here in Desmos, if you want to do a square root, it's right there. But if you don't see it there, you've got to come over here to your functions. And you got to scroll quite a ways down. Number theory. Under number theory, you will find your nth root. So I'm going to go ahead and type in that. And remember, you have to use an x. And that's obviously not the same thing. Now, because I want to save time, I want to be really efficient with this. So the 4th root, the only thing that makes the first 2 options different is that the second one has another m out in front, which in this case we'll use an x. So I'm just going to edit it. Okay, still not close. The next one has a cube root, and then it is just an X on the inside. Aha, we have a winner there. Oh, wait, it's like erroring on us. I'm gonna put I just put a 1 in there. It was erroring because there was no exponent. Probably I could have just deleted the exponent, just deleted it, and that works too. So that matches, that's what I'm looking for. But, supposing it didn't, I would have to come over here and put in the x squared, and that's not correct. So that took a little bit longer. Part of that was I got hung up on typing that in, and that can happen on your EOC as well if you're trying to type in something you never typed in before. So not to beat a dead horse, but it is really important that you are practicing on Desmos during the review, so that stuff like this is stuff that can be worked out, because if this happens during the test, you're going to be unsure as to whether you're doing it right. So okay, so that wraps up this particular chunk of the review, and we will continue on with this next class.